This is SciByte, episode 124 for March 25th, 2014. Hi, everyone, and welcome back to SciByte, Jupiter Broadcasting's weekly science podcast, live on a Tuesday and fresh on a Wednesday over at jupiterbroadcasting.com. My name is Chris, and joining us every single week is our host, Heather. Hey there, Heather.
Hey there, Chris.
Hey, Heather, happy science to you.
Happy science.
So, what are we going to talk about this week?
Today, we're going to take a look at evidence of inflation at the start of the universe, water in Earth's crust, giant stars, frozen moss, spacecraft updates, curiosity news, and as always, take a peek back into history and up in the sky this week.
Sounds like a packed show, Heather. Why don't we kick it off with the news? All right, Heather, what is our first stop on the science train tonight?
All right, the last untested prediction of Einstein's theory of general relativity, finding gravitational waves, and seeing the echoes of the inflation of the Big Bang have now been seen.
Whoa, that's huge, right?
Yes. So, Big Bang, nothing, giant explosion. Now, at the first, very first, what we're looking at, we can go back and look at about a minute after the Big Bang. Now, we're looking at the first trillionth of a trillionth of a trillionth of a second.
Wow.
Of the universe. And this is where it goes from nothing to huge in an exponentially fast rate. And that inflation caused... So it was back in 1980 that this started, that this theory was there. And essentially what it is it's the propulsion. It's not ascribing going from nothing to the size that we are now. It's that first burst. It was like giant, like nitros. Like hitting the nitrous.
Hitting the turbo button.
Yep, hitting the turbos, and then everything just keeps going.
Okay.
So it's kind of this weird thing where we can see the cosmic background radiation, which is, look up into the sky and you see vaguely uniform with little bits, slightly differential temperatures, which essentially means slightly different gravitation and density. So we can see that at the very beginning of the universe, there was a little bit of, differences there, very microscopic. But those differences is essentially what ends up being stars and galaxies and such.
But when it expands out?
Yeah.
Wow.
Now, this is where it really gets weird. Inflation was, starting at nothing. It's a very small patch of the inner universe. And you have this repulsive gravity material. And what it's meaning in the end is that you're expanding, but the density is not lowering. So it's because of the energy, it kind of seems like it's a violation of the conservations of energy to say, I'm going to take this, stretch it out as far as I want to, and it's not going to get any thinner.
Mm-hmm.
But it's this weird feature of gravity where it can be, a gravitational field can be negative. So expanding at this constant density means you get more and more energy in the form of matter. And at the same time, you're having more and more negative energy from the gravitational field. So it's this weird balancing act of energy that, for some quantum mechanical reasons, that will bend your brain the more you try to figure it out.
Okay.
You have this tiny little part of nothing that expands to a huge field, essentially, with the same amount of stuff. So it can mean that the total energy of the universe is kind of zero. But what this result is saying is that, we have the cosmic background radiation, and we can kind of see the after, the glow from that. And we have the temperature non-uniformities, which means, a little bit of density differences. But that in itself is not proof of inflation. Because how do we see the fluctuations? We couldn't see exactly how they were produced. Now, in this new some new data from I believe it's the observatory in the Antarctic, where we're able to see these fluctuations in the gravity itself. It's coming out in different polarizations. And so they're able to look at specific parts of the polarization of this light in order to see the essentially twisting what it would be gravitational waves. And it's really crazy, but it's semi-direct evidence. Now, the actual seeing of actual gravitational waves might be actually seen in the next few months. This is just the start of all that data.
Wow.
Now, of course, there are some scientists who say, yes, we see this, and yes, everything explains that would be the inflation, because this type of gravity wave at the very start of the universe is different from everywhere else, in different parts of time.
Okay.
So, yes, that's exactly what we see there. Is there a chance that it's something else? Yes, of course, because we weren't there. But most likely what we're seeing is that. We're seeing this kind of thing. Now, I'm expecting this is going to be the major, if not the major, one of the major science events of this year. If it gets some sort of gravitas to the situation, in 1993, the Nobel Prize in Physics was awarded for finding pulsars that strongly supported ripples in space-time, this sort of gravitational waves, but it wasn't even there yet. I mean, it was sort of, hey, we kind of see this. And then in 2006, there was another Nobel Physics Prize award for discovering the temperature changes in the cosmic background radiation that says, hey, there were some differences there. So this isn't the thing, but
they're celebrating. I mean, they think it's
video.
huge. Yeah.
You have to go see this video. There's a young man, well, college, and he's out standing in front of this street, and he's like, hey, I have this data. I'm about to go surprise Dr. Linde, who was one of the original authors of the papers. He didn't do the original whole idea of it, but he was one of the co-authors of the original kind of papers that were going around. And so this guy's like, all right, so I'm going to go up to his house and tell him the results. So you can see him walking up the driveway, knocks on the door. He's like, so I see R sigma at 0.2. And, essentially it's making the guy the gentleman is just kind of standing there looking at him. He's like, say that again? And his wife's like, you had discovery? She comes over and she hugs
yeah, she knew all about it. She knew immediately what it meant.
Yeah. And so the older gentleman's just kind of standing there. He's like, say it again. So he said it again. And he asks him to repeat it 3 or 4 times.
What?
He's like, no. It's like, no, say it again.
I mean, that must be so huge to just be, to have this theory at one point and then so much later down the road, somebody comes along and it's like, yeah, well, I think I just validated what you theorized. And what a fundamental question to answer too. Yeah.
And it's, older gentleman was like, yeah, I was trying to figure out who was at the door. I thought it was a delivery. And it was a delivery. 30 years in the waiting.
Yeah, no kidding.
But this is amazing. It's really kind of crazy amazing that I didn't know, I wasn't sure when this kind of discovery could be made or what we were going to do with it. So it's very interesting that we were able to find this.
It's incredible.
And I'm really looking forward to what the next couple months will be leading us into.
Yeah, absolutely. Well, I bet there's one place we could find out more, and that's on a future episode of SciByte, right, Heather?
Yes, and if you're interested in data from now, there's a ton of extra stuff in the show notes themselves and other links that you can go check out. But
packed, including a couple of videos you guys can check out if you're interested. It's a huge story, And I bet you'll hear us weeks down the road. Heather will be like, well, remember back in SciByte 124 when we made this announcement? You'll probably be hearing that said for a long time because I think this is going to be a story that we'll keep talking about.
Yeah, you'll probably hear that once or twice this year.
All right, Heather, well, why don't we take a little pause right here? Something really cool going on right now. So we had the Linux Action Show 300 swag. That wrapped up a couple of weeks ago. And now folks are getting their swag. And so we've got a bunch of really great pictures over on the Instagram.com/Jupiter Broadcasting Instagram account. And Angela's been leaking new pictures of the studio setup as we are in progress on getting that all put together. Right now, you see pictures of some of the soundproofing I ordered, some of the light upgrades, and my desk where I'll be working from. Not recording from, but working from. And also some great pictures of folks wearing their Jupiter Broadcasting swag, including somebody taking a picture with Richard Stallman, which was a good one. And there are coins and all kinds of good stuff. So it's a good place to check out. You don't even have to be an Instagram user just to look at the feed. Instagram.com/Jupiter Broadcasting. And if you have a last hoodie or t-shirt or whatever it is and you'd like to get on our Instagram feed, be sure you send it over to Angela at JupiterBroadcasting.com. Or if you post it online, make sure you tag her on one of her social networks. And then she'll put you on our feed, and we'd love to see it. You guys get to look at us all the time. It's neat to get to look at you once in a while. Have the cameras turned around on you. So Instagram.com/Jupiter Broadcasting. And with that filed, Heather, I think it's time for the News Bite. Okay, what are we going to cover in the News Bite?
So we've had the first terrestrial discovery of ringwoodite, I'll get to that in a minute, that actually confirms the presence of massive amounts of water 400 to 700 kilometers beneath the Earth's surface.
Wow, that's way down there.
Yes, ringwoodite is a form of mineral believed to exist in, we think it would be large quantities, high under pressure in what's called the transition zone of the Earth's crust. Now, it's known that it can contain a lot of water within its structure. Now, not liquid as we would see it, but what they call hydroxide ions, which is oxygen and hydrogen atoms just bound together, but in such a way that it equates to water. Now, we've seen it in meteorites, but until now, we've never actually seen an Earth sample because it's hard to conduct field work in the Earth's crust that low, that deep in the Earth.
Sure, I would imagine.
So it was actually an accidental discovery, kind of oddly enough, as a lot of science is. They were looking for a different mineral when they purchased this 3 millimeter wide, dirty looking, commercially worthless brown diamond. They're like, kind of yuck. And there was a grad student who was looking at it very closely and said, this was brought to the Earth's surface by a certain type of volcanic rock that is the most deep of all the volcanic rocks. So this is pulled up from underneath from the Earth's crust, which is why we're able to see it itself.
Yeah.
And it wasn't even visible to the naked eye. It was buried in the surface of this. And it actually, they discovered a tiny little section of it. So then it went years of analysis. They're just now starting to come out with the information about it. At infrared spectroscopy, X-ray diffraction, just every kind of test they could throw at it to confirm that it was ringwoodite, because this would be is the deepest, the only Earth sample of it that we would see. So you really want to make sure that you're not going to flub up on this,
because the implications are pretty big, right?
Yeah, so there's like 50 years worth of theoretical and experimental work by geophysicists, seismologists, trying to understand the makeup of the Earth's interior. They can do a lot of sort of extrapolation with seismologists from earthquake. You have the waves, and it can traverse through the Earth's crust, and you can kind of track it that way.
Yeah.
But scientists have been pretty divided about what the composition of this is, whether it's, has this hydroxide, essentially water, or whether it's really, really dry. And this actually shows that it's a significant amount of water. Now, that's 1.5% of its weight. Now, it doesn't sound a lot, but theories are that it could trap a lot of water down there. I mean, it provides some strong confirmation that there are definitely local wet spots, at least deep in the earth, that might contain as much water as all the Earth's oceans put together.
What?
So deep in the Earth's crust, you have this hydroxide, water in the form of hydroxide, that pretty much might be the same as all of the oceans. And knowing that has a lot of implications for volcanism, for plate tectonics, for how rocks melt, for crustal shifting.
Oh, yeah, I bet it does.
We have all these different things that would really be changed whether we know this or not.
Wow, that is really. I didn't even think about like plate tectonic impacts or volcanics. Is that the right word? I didn't even think about the impact on that, but that that gives you that does, like the chat room says, that's deep. That's really deep.
That's very deep. Heaven's Revenge in the chat room said, the deepest mine is almost 4 kilometers. So at the limit at 400, that's 100 times deeper than any of the mines we have now. So,
and sometimes in the deepest case, 660 kilometers beneath the Earth's surface? So that's just incredible.
Oh, yeah.
Wow. All right, Heather, why don't I bring the band in so that way we can kick off the 2 Byte News? Hey! The band's all pumped up because I told them our first story in the 2 Byte News is a big story. What is it, Heather?
Yes, literally very big. In the southern hemisphere, in the constellation Centaurus, they've actually revealed the nature of a massive yellow, what they call hypergiant star.
A hypergiant, I like it.
That actually turns out to be one of the largest stars ever known. Now, a yellow hypergiant, a yellow star is kind of like our star. This is just hypergiant. There's only 8, I think, of these known.
Oh, wow.
There's not a lot of hypergiants known.
Okay.
Now, the latest measurements actually put it in the top 10 largest stars that we know of. And one of the largest yellow hypergiants that we know of for similar. Now, if it was placed where the sun is, it would extend out well past the orbit of Jupiter.
Oh my gosh.
Now, as I said, only 8 of these have ever been identified in the galaxy. They're some of the brightest stars known. If this star was placed just 32 light years away from Earth, it would cast a shadow. It is so large and so bright.
Wow.
And what's really puts a twist on this whole thing is it has a companion star. Now, relatively small as far as relative, I'm making air quotes here, because it only crosses the line of sight every 1,300 days or so. Now, on its own, it is a large star. It has about 6 solar masses, about 400 times wider than the sun is. So it's kind of large on its own, but in comparison, small. Now, what makes it really weird is that a normal star should be about 10,000 times fainter than the hypergiant. So we shouldn't be able to see it. But what we're able to do is we're not seeing it itself. We're looking at regions gravitationally controlled.
Oh.
Because they are so close that the surface distances they're less than 3 times the distance from the sun to the Earth. Which, if you're thinking about a star and a star sitting that close to each other, it's crazy, which means essentially that their atmospheres are touching. It looks like a really weird peanut shape. So these stars are so close, they're kind of touching each other. And so this is a really crazy little system. We have this, now that we've had this further data on it, we see that it is one of the largest stars we've ever seen, and that it has a companion star, and they're kind of not just gravitationally involved with each other, but actually sort of touching.
It's like a moon for the star, but it's a star. I mean, right? It's being orbited by another, like the moon orbits the Earth in a sense, but
sort of. But if the moon had an atmosphere and if it was so close, our atmospheres
Right. They were
connected to each other.
Yeah. It was closer. Yeah. Wow. That is a big star.
Yes.
And oh, look at this. They have some stellarium screen grabs of what the region of space looks like.
Nice. I thought that looked familiar.
It is. It's the tool we've been using.
Yeah. Denny from the chat room says, wouldn't they collide? Yes, they're definitely watching this system as to what's going to happen in the future for this star system. So they're kind of watching it to see what's going to happen, because this is really, the fact that they are touching really makes it kind of on the edge of when is it going to dive into it?
Mm-hmm.
Or why is it stable for a long period of time?
Mm-hmm.
So there's science coming of it. It's whether the science makes sense to what we think should happen or not.
Well, I'll tell you something that does make sense. Bringing moss back to life. We got a good story for all the moss lovers out there, don't we?
Yes.
I'm sure it's a big category, Heather.
Yeah, everybody in the likes frozen moss, right?
Of course.
Now, researchers at the British Antarctic Survey and Reading University have actually shown that after 1,500 years frozen in the Antarctic ice, moss can actually come back to life and continue to grow.
This gives me hope for humans. If they could just figure out what the moss is doing right, space travel.
Freeze us?
Yeah, they'd freeze us, and then it'd be long space travel, but it's probably the most realistic and practical space travel we're ever going to see.
Because it's a really easy step between moss and humans.
Well, I'll give them that. They got some work ahead of them.
Okay. What they're able to see but this does show some very interesting things for long-term survival in any plant. We've seen similar timescales in bacteria, but nothing this complex as moss.
We're talking 1,500 years?
Yeah. Now, it was probably a couple decades old when it was first frozen. And they're able to take cores of this moss from deep in the frozen banks of the Antarctic. Then they were able to, very carefully keep it isolated from any contamination, place it in an incubator at normal temperature and light levels, and after a couple of weeks, the moss began to grow. Now, using carbon dating, they definitely identified the moss to be 1,530 years of age, maybe even older. As to where they saw it, its location, they kind of see that it may be even older than that.
Huh. Well, we've heard of, I guess this is probably the most complex thing I've ever heard of being frozen, but it's not like the story doesn't blow me away, other than it makes me think, I wonder what else is sort of like moss or along the same lines that also would survive a freezing process. Like maybe there's a whole lot of other things we don't know about.
It's not just the freezing and unfreezing, it's the length of time that is the big step here, because there's been a number of things where it's frozen in the Antarctic ice.
Right.
Glacier moves back. We can actually see something growing. It's the fact that this was, 1,500 years of complete frozen, where it's doing nothing except sleeping.
That is incredible. Well, Heather, I think the only way we can top that is by doing a spacecraft update. Now, I believe I have discovered guaranteed proof of water flowing on Mars. Heather, what say you?
Probably not.
Okay.
Well, if you're talking about this next story.
Right, I am.
So, images from the Mars Reconnaissance Orbiter show a new channel in Southern Hemisphere region that appeared between November 2010 and May 2013. Now, you see a new thing like that on Earth, you say, hey, water. Not so much here. And it's a very long time frame, so it's kind of trying to figure out where it actually is, when it happened. But they're able to see is these kind of gullies or ravinae, gullies, landforms, common in this part of Mars. They tend to happen in these kind of southern highlands or mid-latitudes. Now, it's unclear, what season happened in, but probably these kind of things happen in the winter when the temperatures are so cold that carbon dioxide, rather than water, has actually probably played a key role in it. So there may have been some carbon monoxide, ice, that either formed or melted, but was able to trigger off a little bit, so it kind of landslided and cleared out an area. They're actually able to see some debris at the bottom of the new ravine,
Oh, no kidding.
but
You're saying I should cancel my kayaking plans on Mars
probably.
for now? Okay. All right. Well, you keep me posted.
Yes.
Hey, while we're talking about Mars, should we do a curiosity update?
Let's go.
And liftoff of the Atlas V with Curiosity.
Touchdown confirmed. We're safe on Mars.
Okay, Heather. So how is our favorite rover doing?
Alrighty, it has just pulled into a terrain full of curvy rock outcrops. It's a very cool new location for it. They're actually stopping here, and this is going to be an investigatory area. They're already kind of getting ready for their cameras and spectrometers and everything on the robotic arm. They've got the mast mounted, the laser, and high-resolution cameras are kind of being used to decide where the best spots for drilling and sampling are. They've got the arm readying to go out and start drilling into some of this rock. And it's layered. You can see it's very clearly some layered rock here.
Yeah.
Which they've actually been looking forward to because they kind of piqued their interest from the Mars Reconnaissance Orbiter imaging, where they saw these 3 different types of terrains exposed to fairly dust-free surface area. So they were aiming more towards this area as a point of interest between here and Mount Sharp, where they're trying to go. So
are they doing any science in this area while they're stopped, or are they just sort of preparing for science?
well, they've stopped right now, and they're preparing for science. They're getting ready to do some. Yeah, they are. They're getting ready to do some drilling. They just have to figure out where they want to drill.
I
They
see.
make sure you're very careful about where you want to drill, so that you're not going to be putting all of the scientific equipment through.
Yeah, and they got to
You
make
know,
their observations before they go.
Yeah, every time you use it, you always run the chance that you can't quite crawl AAA.
Yeah.
Drive your little scientist out there to tap on this or that and fix it.
Although if they want
So-
to pay for the trip and the return trip, I'd be willing to go.
Well, of course you would.
I could do that.
Yeah, I'm sure there might convince a couple people. Might take a few years though.
Yeah, I'd have to figure out a way to do some shows on the road, as it were.
On the road, on the road in the sky.
Yeah. Any other thoughts on our curiosity update?
No, we're just kind of looking to reach the base of the mountain sometime mid this year, hopefully.
Yeah.
But
All right,
we've got,
Heather.
we've got a lot of stuff between here and there.
Jump in the time machine with me. It's time to go back in time. Here we go. Woohoo! Yeah, nothing like a little local space-time distortion to wake you up in the evening. Here we go. This week, the time machine takes us to 65 years ago, March 28th, 1949. Heather, what happened this week in science?
The term Big Bang was coined.
Oh.
This is definitely a history point that I chose specifically for this week. And it was funny because it was unintentionally coined by a guy who didn't believe in it.
Oh, really? Was he being facetious when he said Big Bang?
Possibly. He was on the radio and he was talking about it. He was a steady state person. He was not, a believer in, what we call now the Big Bang. And he was kind of talking about it. He's like, one idea, that the universe started in this finite time thing with this huge explosion. This Big Bang idea seemed to me to be unsatisfactory. And then everyone else kind of took on it. The
That
term stuck.
Is kind of funny and amazing, too, that it,
Yes.
the
The
shows
term
you.
was started by someone who didn't believe in it.
Kind of incredible. All right, Heather. Well, stand by. I got to recalibrate the SciByte 2000, so that way we can look up into the sky this week.
Alrighty, on Thursday, March the 26th, about an hour before dawn, you're going to see Venus near the thin moon, crescent moon, about east to southeast in the sky. We've got Venus, on the whole this week, is the morning star. It's going to be seen during dawn hours in the east-southeast. We've got Mars, rising about 9 p.m. in the southeast, with the star Spica, blue-white star, about 6 degrees to its right. That's about the distance between your 4 fingers, held at arm's length. And they're going to be at their highest point around 2 a.m. with then Spica to the lower right of Mars. And we've got Jupiter,
Heyo.
only planet visible right now in the evenings, high in the southeast as night falls. You can see it crossing nearly overhead for mid-northern latitudes about 8 or 9 p.m. It's going to be setting in the west about 3 a.m. Then we have Saturn, not to be forgotten.
No.
At about 11 p.m., it's going to be rising. The highest in the south around 4 a.m., way far to the left of Mars and Spica. But we've definitely got Venus and Jupiter, our big stars this week, as usual.
It's actually a pretty good turnout, really.
Yeah.
And of course, Heather outlines all of that in the show notes. And I always like to say, hey, if you're out, you see something, maybe you're out on a walk. Like, what the heck is that? Maybe you got the smartphone in your pocket. Go over to jupiterbroadcasting.com, click on or tap, I should say, if you're on the smartphone. Tap on SciByte 124, scroll down to the bottom of those epic show notes, and you will find all of that listed out there for you. Heather makes copious documentation. Heather, is there anything else we want to cover this week?
Not that I can think of.
Well, very good. It's good to be back. Sorry we missed last week, everybody. And always don't forget, you can always check jupiterbroadcasting.com/calendar for updates on show production schedules. Heather, I hope you have a great week.
I hope you do too.
And thank you for the great show.
Thank you.
Thank you, everyone, for tuning in this week's episode of SciByte. I'd love to have you join us live over at jblive.tv. Don't forget, we're live on Tuesdays, and the show's out for download Wednesdays over at jupiterbroadcasting.com. And you can subscribe to the RSS feed and just get the show automatically every time we have a release in your favorite podcast client. Okay, everyone, thank you very much for tuning in this week's episode of SciByte. We'll see you right back here next week.